And it is time to get rolling. Welcome on, welcome all. It is College Geometry, class number 12. And today we are going to continue with our discussion of circle geometry. Last time we learned about chords. We learned about the different rules regarding chords and how they interact with radii and inscribed angles, angles that are inscribed in the side of a circle, angles that are inscribed in the center of the circle, and all sorts of things like that. Today we are going to carry that forward and really just do the same kinds of things, but we're going to extend it a little bit to cover two other areas, and those areas are secants and tangents. Both of them are lines that start, or line segments really, that start outside the circle. Of course, a line can't start or end. A line goes on forever in each direction, so it has to be a line segment. But it's a line segment that starts outside the circle and interacts with the circle in one way or another. A secant simply means a line segment that runs through a circle from one edge to the other. In this diagram over here, the line segments USR and UQT are both secants. And the reason why they're both secants is because they both start outside the circle and run through the circle. In other words, if you have any point outside of a circle, there are really three possibilities. One possibility is that it's going to miss the circle altogether. If you run a line segment like that, well, we don't have to learn about that because that simply is, there are two things that have nothing to do with each other. There's obviously no relationship between the circle and this maroonish line that I've drawn over here. A secant is a line that goes through a circle and hits the circle twice. If it hits the circle twice, then it is called a secant. As you can see from this diagram, USR, in other words, this one over here, that is a secant. UQT, also a secant. The third type of line segment with regard to a circle, which we're going to see later on, is the third possibility. The third possibility is where the line touches the circle only once. In other words, where the line just kind of grazes the edge of a circle. That, as we'll see a little bit later on, is called a tangent to a circle. Don't confuse that, of course, with the tangent in trigonometry. Tangent in trigonometry meant the relationship between the opposite divided by the adjacent, the ratio between the opposite and the adjacent side of a circle, which was based on, you could figure it out using the trigonometric relationship that we saw before. So, one thing has nothing to do with the other. This tangent has nothing to do with that tangent, but they both happen to be called the word tangent. But for the time being, we're only learning about secants, because the two lines that are over here are both secants. And we're going to learn a series of rules over here. As usual, you don't have to memorize the rules, you just have to know that they exist and know where to look them up. And let's take a look at our first rule of the day. Our first rule of the day is that if two secants intersect outside a circle, the measure of the angle is 1/2 of the difference between the arcs that the secant intersects. Now, as you'll recall from last time, if we had an angle that intersects on the edge of the circle, well then, this angle, we'll call it angle A, let's say, is 1/2 of whatever this arc is. If this arc is 100 degrees, then angle A was 50 degrees. Well, when you're talking about the secant, of course, intersects outside the circle, and therefore the relationship is 1/2, but instead of being 1/2 of the whole arc, it's 1/2 of the difference between the two arcs. So let's say this small arc SQ, is 40 degrees of the whole circle, and the big arc, RT, is 120 degrees, which is 1/3 of the whole circle, which it looks probably a little bit less than 120, but let's pretend it's 120. If we want to figure out what theta is, theta being angle QUS, or you can call it TUR, really you can call it any of those things, but the thing that's marked theta, in other words, this angle over here, would be 1/2 of the difference between 120 and 40. What's the difference between 120 and 40? Hopefully we can all realize right away that the difference between 120 and 40 is 80. And the theta is 1/2 of 80. So therefore, of course, theta equals 40 degrees. Simple enough. Now, of course, it happens to be the same as the SQ arc, but that's just a coincidence. If I told you, for example, if I changed up the story a little bit, and I told you that, how do I get rid of all this stuff over here? Alright, I think if I keep doing this, it'll get rid of all that eventually. Okay, what if I told you that SQ was 30 and RT was 100 degrees? So who can tell me what theta is now? Can anybody figure it out? What that angle is? 35, that's correct. Why? It's 1/2 of the difference between the two arcs. The difference between the two arcs is 100 minus 30, which is 70, and 1/2 of 70 is 35. Very good. Okay, so that is the secant theorem. Let's take a look at our next rule. Okay. Our next rule is that if two secants intersect outside a circle, as of course they're going to do in most of these examples over here, the product of the length of the whole secant and the part outside the circle is equal to the same of the other secant. That means the little part, the part outside the circle, times the big part, which means the whole segment, equals the same for both secants. So in this case, AB times AC, well actually it says down here the same thing, but I'll write it up here anyway. AB times AC, in other words the part outside the circle, times the entire secant, equals the same for the other secant. AD, which is the part outside the circle, times the entire secant. So if I told you, for example, that this was, let's say, 7, and this was 5, and let's say I told you BC was 8, and I wanted to ask you what is DE. How would you figure that out? Okay, well let's establish our ratio first. AB is 7, times AC, which of course is 7 plus 8, which is 15, equals AD, which is 5, times AE, and we don't know what AE is. So we'll simply call it x. And then we just solve this like we would any very simple algebraic equation. 7 times 15 is 105. Equals 5x. Divide each side by 5 in order to isolate x. And you have x equals 21. Now if x is 21, so what is DE? X is the whole secant. X is the whole AE. And we know that AD is 5. So that leaves how many left over for DE over here? That leaves 16 left over for DE over here, right? If the whole thing is 21. Okay. Simple enough. That's rule number 2. And in learning these rules is relatively simple. Obviously, a little bit later on, we're going to apply them. Has anybody had a chance to see the homework for these classes, by the way? Homework number 6? A lot of very interesting problems. A lot of, very involved and complex problems, which, again, all you need to know are these rules. That's all you need to apply. And I'm going to try a couple of them. We're going to look at a whole bunch of practices. Going through these slides is only going to take a few minutes. We're going to spend most of this class on practicing, because practicing is how you learn these things. Okay. Now let's discuss tangents. Tangents is a line. A tangent is a line that starts outside the circle and touches the edge of the circle at only one point. Unlike a secant, which runs through a circle and touches the edge of the circle at 2 points, a tangent runs alongside of the circle and kind of ticks it as it goes by. It just touches the outer edge at 1 point. In this case, line PL is tangent to circle O because of the fact that it touches the edge of the circle at 1 point, which is point P. Okay, that's what the definition of a tangent is. Let's take a look at a couple of rules with regard to tangents, and these, of course, are all logical. First rule is that the radius of a circle is perpendicular to the tangent with which it intersects. If you have a circle, now this line over here, OT, this line segment over here, is a radius, because it's a point from the midpoint of a circle to the outer edge of a circle. If line AB is a tangent to the circle, then it has to be perpendicular to the radius that hits it. Since the radius OT meets the tangent AB, they have to be perpendicular to each other, which means you have a right angle over here. Okay, simple enough rule. If you draw a few circles and draw a few tangents and draw a few radii that hit them, you'll see that it works every time. And of course, the logic behind it is very simple. What is the shortest distance? A straight line. A straight line is always going to be, the radius is always going to be the shortest way to get to a particular point on the outside of a circle. So a tangent really does the same thing. It hits that point by using a direct line going at it as well. Draw it a few times, hopefully it'll become self-explanatory why that is. All right. Number 2. The measure of an angle formed when a chord intersects a tangent is 1/2 of the intersected arc. This is really the same rule that we discussed yesterday. Remember yesterday we discussed a rule that if you had an angle that's inside a circle, this angle theta, was 1/2. Let's say this is A and this is B. So theta was 1/2 of arc AB. All this middle rule says is that the same thing applies when one is a tangent. Now, in this case over here, really both were not secants, but both had their edges on the edge of the circle. Well, the same thing is true when you're talking about a tangent and a secant. In our example, in number 2, in this diagram over here, which one is the tangent? Which line segment is the tangent? Who can tell me? BC is the tangent. That's correct. BA is really not a secant or a tangent. It's just a line segment that it's a chord. Really, BAB is a chord. Angle ABC, in other words, this angle over here, is 1/2 of arc AB. Measure angle ABC is 1/2 of arc AB. Again, really for the same reason that it works in this diagram. Rule number 3, on the bottom over here. If you have two tangents to a circle from the same external point, the tangents have to be equal to each other. AB equals AC. By the way, how many tangents can there be to a circle from one point? What's the maximum number of tangents there could be to a circle from one point? Just 2. Yeah, exactly. It cannot be any more than 2. I mean, think about it. Look at the diagram here. Let's say even forget the diagram. On top, I'll draw another circle over here, and I'll draw a point A over here. From point A, now there could be lots of different secants. See, there could be this secant, there could be that secant, there could be that secant, there could be lots of secants that are floating all over the place. But in terms of tangents, there are only 2 possible tangents. There's a tangent that touches this side of the circle. I'll assume that it was close enough. Not very close, but all right. And there's a tangent that covers that side of the circle. Those are the only 2 possible tangents that could apply from that point to that circle. So back to the bottom over here. This is point B. This is point C. And AB has to equal AC because both tangents to the same circle have to be equal. Another rule that makes common sense. Okay. Another rule, and we're going to apply all of these. We're going to discuss all of these, so don't panic if you don't remember all of them. We're going to discuss them as we move along, and I hope everybody will participate in when we do the practice ones. First of all, if a tangent or secant, or 2 tangents, form outside a circle, the angle between them is 1/2 the difference between the arcs. Just like with 2 secants. This is really the exact same rule as we applied when we talked about 2 secants. On the example on the left, who can tell me what angle x is? Remember, it's the difference between the intercepted arcs. So what is the difference between the intersected arcs? What are the intersected arcs, for starters? Okay, let's take a step back. What are the intersected arcs? The answer is 70, but yes, but what are the intersected arcs? What are the 2 intersected arcs? The first arc is AE, right? The second arc is AC. Both of them are intersected by the secant and the tangent running from B. The difference between AE, which was 100, and AEC, which is 30, is 70. What's 1/2 of 70? Obviously, 1/2 of 70 equals 35. So x equals 35 degrees. Okay, let's take the one on the right. What if I told you that this is BC, arc BC? Well, there are really two arc BCs. The short way. The short arc BC, I told you, was 120 degrees. So what's angle A? Can I figure out, based on this information, what angle A is? This angle, angle theta over here? If so, yes. Don't just tell me the answer. Tell me, how would I figure it out? Right, exactly. The big arc BC, the one going around the left side, has to be 240 because, remember, a whole circle has an arc of 360 altogether. So the difference between the big arc and the small arc is 240 minus 120. And theta is 1/2 difference. So in this case, it's 1/2 of 120, and so of course that means theta equals 60 degrees. Same rule as we discussed before a few minutes ago. Next rule, similar to the one that we discussed regarding chords the other day. This is really our last rule, and then we're going to look at a whole bunch of different problems. The length of a tangent from point A is the mean proportional between the part of the secant outside the circle and the whole secant. Remember, when you talked about two different secants, they just simply multiplied and equaled each other. The tangent, on the other hand, the rule is slightly different. The rule is that the x in this case is the mean proportional, which means when you have a proportion, the mean proportional is the thing that's in the middle, or in the bottom of one and the top of the other, between the outside segment and the entire segment. So in this case, that means 4 is to x, as x, and remember, because x is the mean proportional, so x is what is in between, x is what's on the bottom of one fraction and top of the other, is to what? What should go on the bottom over here? This is the whole secant. How much is the whole secant? 16, that's right. Why is the whole secant 16? Because the outer part is 4 and the inner part is 12, which means altogether that's 16. How do we figure this out? Cross multiply like any other equation. X times x is x squared. 4 times 16 is 64. And of course your answer, take the square root of each. So your answer is actually plus or minus 8, but because it is a length, we drop the negative value and only apply the positive value, and x equals 8. Okay, so we've discussed how many rules? We've probably discussed about 6 or 7 different rules so far. I'm going to look at some examples. And just as we did last time, what I'm going to do is I am going to put my whiteboard here, and I am going to pop up my monitor here. Okay, can everybody see the guy waving the white flag? Okay, does anybody else here feel like waving the white flag? Or are we doing well here? Okay. All right. Question number 1. This is not something that we learned today, but it is something we learned last time, so we're going to do question number 1. Given circle with 2 chords is marked, find x. How do we do this? This is something we didn't learn today, but we learned last time. So how do we do this? How do we figure out what x is? Anybody remember? Remember, when you had 2 chords that were intersected, they were proportional. So each side multiplied by the other equals the same for the other chord. So in this case, it would be 3 times x. Okay. 3 times x equals the other side, which is 4 times 6. And again, the reason for that is because these are two chords, which means the sides of the chords are proportional to each other. So 4 times 6 equals 3 times x. And so, of course, that means that 3x equals 4 times 6, which is 24. Divide each side by 3, and you have x equals 8. Simple enough. Okay. Let's see if 8 was the correct answer, and of course it is. Okay. Let's take a look at the next problem here. Given circle with diameter perpendicular to the chord, okay, find x. How do we do this? This is also something that this is again something we learned about last time, but we still should be able to figure it out. How do we do this one? This one's a little bit more complex, not much more complex, but a little more complex. How do we do this one? Well, here we have the same rule. Did anybody remember from last time that the diameter going through a chord that is perpendicular to it is its bisector, which means it splits it in half? So if this side is x, what do we know about this side? It also has to be x. So if we use the chord formula, which we just discussed, we can do this times this equals this times this, which is really the same formula we just applied a minute ago. So let's try x times x, which is x squared, equals 5 times 2, which is 10. If you take the square root of each side, x is the square root of 10. That's a very simple one as well. Oh, incorrect. That's strange. Really? Huh. I know why. Yeah, okay. You know, what mistake did I make? You see what mistake I made? Very simple. This 5 was only this red area, not the whole thing. That was the mistake that I made. This side of the chord is not 5. This side of the chord is 8. Because if this is 5, that means the whole diameter is 10. If the whole diameter is 10, then because this is 2, so this side has to be 3 over here, which means this is 3, which means that it's really 8 times 2. 8 times 2 is 16, so it really should be 16 equals x squared, and if 16 equals x squared, x is 4. Okay. Now, how about this one? I want you to help me with this one here. How are we going to do this one? We've got two secants. What's the rule with two secants? The rule with two secants is that the outer side, the outer length, multiplied by the entire secant, equals the outer length times multiplied by the entire secant of the other one. Okay, so the lower secant. What should we do for the lower side? What two numbers should be multiplied by each other? The outer part is what? Okay, 6 times 16, good. Because that's the outer part times the entire thing. What about the other side? What about the top? What's the smaller part? What's the part of the secant outside the circle? 4. What's the part inside the circle? What's the whole secant? Well, I mean, that might be. I haven't figured it out yet. But what's it in terms of x? It's not just x. X is just the part inside the circle. The entire secant is actually x plus 4, right? Do you see why that is? Because x is the part on the inside and 4 is the part on the outside. So it's really x plus 4. So algebraically, what I'm going to do here is I'm going to do 4 times x plus 4. Now we can do this like we would any other algebraic equation. 6 times 16 is, 96? Okay, equals, and here we can distribute it out. 4 times x is 4x. And then we have to multiply the last part here too, which is plus 16. Then we can subtract 16 from each side. And we have 80 equals 4x. And you divide each side by 4, and you get x equals 20. So if x is 20, that means, well, x is 20. So, okay. Okay. Next! Okay, number 4. Similar problem. Can anybody help me? What are we going to do with number 4? What's the relationship we're looking for? Okay, well, let's take the top first. Okay, yes, exactly. We got to figure out the length of the lower secant, which is what we're looking for here. Good. So what is the top secant's ratio? Outer part is 10. Times the entire thing, which is 10 plus 14, so it's actually 24. Right? Remember, you got to do the entire secant. Equals the bottom part, which is 8 on the outer part, and x on the inner part. On the entire thing, excuse me. The entire secant is x. Right? So you have 10 times 24, which is 240, equals 8x. Divide each side by 8. And you have x being 30. Right? See why that is? Just multiply it out, figure it out what x is here. Okay. Now we've got a circle with two secants again. Same basic question. We should be good at this by now. Who can help me do this one? And anybody besides for Tehila awake over there? Still there, getting a cup of coffee, relaxing, watching TV? All right. Okay. We will press on. Okay. Let's see. What do we got here? Well, here we're going to do the same thing. Let's take the bottom secant first. The bottom secant. What's the outside part? The outside part is 6. What's the whole secant? Whole secant is 6 plus 4, so the whole secant is 10. Equals. Well, again, we're going to do the same thing as we did before. 5 is the outside part. And for the whole thing, we'll do x plus 5, because the entire upper secant is actually the outer part plus the inner part. So for that, we can do 6 times 10, which is 60, equals 5x plus 25, because you have to distribute it, as we did before. So subtract 25 from each side, and you have 35 equals 5x. Divide each side by 5, and of course you have x equals 7. Very good. Simple enough. All right. How about number 6? Number 6 is, again, a slightly different rule. Between it's a tangent and a secant, and so therefore the tangent is the mean proportional between the outer part of the secant and the entire secant. So what's the mean proportional going to be? 6, right? Because 6 is the length of the tangent. So when we put the two fractions, we're going to put the equal sign over there, and we're going to put 6 on the bottom of one and the top of the other. What should I put for the top over here on the upper left side over here? X. That's right. That's the outer part. What about down here? What about in the lower right-hand side? Not just 5. Remember, you got to get the entire secant. 5 is only the interior part of the secant. So we got to do x plus 5, exactly. Okay. Now we got to cross multiply, and we're actually going to get a quadratic equation, but that's okay. We can do quadratic equations, hopefully. So you have x times x plus 5 because that's cross-multiplying, equals 36. Now here, again, hopefully you remember how to do quadratic equations. If not, that's okay. Let's distribute. X times x is x squared, plus 5x equals 36. So over here, you've got x squared plus 5x minus 36 equals 0. Again, this is quadratic equation, so if you don't remember how to do this, we shouldn't have too many problems like this. But yeah, what we really need, you need to set the whole thing equal to 0, then try to factor it. Again, if you didn't take algebra, you might not remember this. Even if you did take algebra, you might not remember this. But you got to factor these, and you have to see what two numbers multiply up to 36 and add up to positive 5. Let's see, 36 would be, well, it's not 6 and 6, not 12 and 3. 9 and 4, yeah, obviously, yeah, 9 and 4 has to be the answer. So you really need x plus 9 and x minus 4 will give you this. And these two results, each one is equal to 0. So x plus 9 equals 0, and x minus 4 equals 0. And this will actually give you two results. X is negative 9, and x is positive 4. And since it's a length, you'd reject the negative one and keep the positive one. So the only one that works is number 4. Okay. Oh, wow. How about this one? How about number 9? How are we going to do number 9? Well, they give you a hint over here. They give you a hint to find y first. Because if you don't find y, there's no way to find x. So the only way to do this is with the chords rule. Exactly. The chords rule is that the two sides of the chords are proportional to each other. So in this case, it would be 5 times 8 equals 4 times y. Again, 8 and 5, 4 and y. So that, of course, 5 times 8 is 40. Okay, so y is 10. So we figured out that y is 10. Once we know y is 10, now we could use the mean proportional rule. Because now you've got a tangent and the secant, which means the x is the mean proportion between the outside of the secant and the entire secant. So again, we're going to put the x on top of one fraction, bottom of the other. How much is this of secant is outside the circle? 5. How much is the secant altogether? Well, we got a 5, and then we got a 10, and then we got another 4. So we got 19 altogether, that's right. So this gets you x times x, which is x squared, equals 95. So take the square root of each side. X is the square root of 95. If you want to reduce that, well, is there any way to reduce that? I mean, they give you right away that, well, yeah, they give you over here the square root of 95, so that should be the correct answer. And that is correct. Okay. What about this one? How do we find x? Well, we'd really have to do the same thing as we did before. We'd really, I don't know, I'm just trying to figure out why they're putting a y over there. I don't see why you even need y. I mean, y is obviously 12 because all tangents are the same. But yeah, I mean, of course, y has to be 12 because all tangents are the same, but I'm just trying to figure out why they even bothered to give you a line with y and give you a hint of find y first. I don't think that you need y. You just do it with the other tangent. What's the big deal? So I don't understand at all why they need to tell you why y is even there and why they give you a hint to find y first. But y, of course, is 12 regardless. And then you would do it the same way as you do anything else. The tangent is the mean proportional, so we'll put a 12 here and a 12 here. The outside is x. The inside is x plus 32. And if you do the cross multiplication, you do x times x plus 32 is x squared plus 32x. Equals 144, or minus 144 equals 0. And so this you can factor into what two numbers multiply up to 144? Positive and a negative, so that would be, how about, 36 and 4. Yeah, okay, that's the only one that works. 36 and 4. So it has to be positive 36 and negative 4. That'll get you up to 144. So on this side you got x equals negative 36, and on this side you have x equals positive 4. So this is the value you take because it's the positive value. Okay. All right. There are some others over here that are really kind of similar to what we discussed, but let's do a couple of these, and then I want to do a couple of the homework examples. I see people are dropping like flies here. All right. Well, press on we go. How about number 5? I don't know is this really that hard? I mean, I'm not seeing it. To me, it doesn't seem that okay. But anyway. All right. Find x. How do we find x? How do we do that? This should be extremely easy, folks. How do we find it? Well, we know that all tangents are the same, right? So if this tangent is 3, what's this tangent? Also 3. And if this tangent is 2, well, then what's this tangent? Also 2, right? So what's x altogether? X is 2 plus 3, which is, of course, 5. Simple enough. They might have asked you something like, if they asked something like, what's the radius of the circle or something like that, then, then it would be a little bit more complicated. Maybe you'd have to use a little trigonometry to figure out some other rules. You'd have to think a little bit more carefully about it. But if they just asked you what x is, that's an extremely simple problem. Okay, now CB is a tangent. Find x. What is x? Oh, wow, that's a good question. How do we figure that one out? Well, the first thing I'm thinking about, whatever this is, all radii have to be the same, remember. So if we figure out what this is, if we figure out what the whole secant is, what OB is, then we could figure out what x is. Really, there are two different ways we could figure out what x is. We could figure out what x is by figuring out what OB is and subtracting 10, and then you get this area, or you can figure out x using the Pythagorean theorem. Either way, how do we figure out what OB is? Let's call OB y. Let's name it y. So based on that, we can say that 20, which is the tangent, is the mean proportional between the part outside the circle, which is 10, and the entire thing, which we called y, which is OB. So now we can cross multiply. 10 times y is 10y. 20 times 20 is 400. So y equals 40. Okay. That doesn't make sense. Of course not. Right, of course. You see why? You see the again. The issue here is that would have been if there was a whole secant, if B went all the way through to the other side. That would actually only work if you extended this line B all the way through O to the other side, because then it would be a secant. So, okay, no problem. Okay, so basically this would work. Y would be 40. Not OB, but that's if B was extended all the way through O, all the way to the other side. Which is fine, because if that was 40, in other words, if the diameter is 40, that means the radius is 20, which means from O to here is 20. So if this is 20, x has to be 20 also. Oh, no, I'm sorry. Well, check that again. You know, let me get this on. I'm trying to describe it, but it's easier if I did it with paint. Okay, there we go. All right, what I was saying a moment ago is that what we really need to do is to extend. In order to get the tangent rule, the secant tangent rule, we really need to extend this all the way through. Now, we figured out that this entire thing, let's say I called this A. So the entire thing, AB we figured out is 40, based on this ratio that I have over here on the scratch pad over here. Really, actually, this is AB. Okay, AB was y, and because 20 was the mean proportional between 10 and the entire secant. Now, so if this entire secant is 40, and this is 10, that means the rest of it, the diameter, has to be 30. And if the diameter is 30, that means each radius is 15. So if this is 15, then this radius also has to be 15. X also has to equal 15. And of course, or you could just figure it out from the Pythagorean theorem, because this is a right triangle. If this was 20 and this was 25, it's actually a 3, 4, 5 triangle, making this 15. So our answer is going to be 15. Okay, all right, let's go to the homework for a minute. There are a couple of questions in the homework. Let me zoom in a little bit over here. Okay, the first page I think is very simple. Let's do 2 of these. If anybody looked at the homework, anybody have any suggestions for which two we can do? Does everybody know how to do this one? This is not such an easy one, but what you're going to need to do is you're going to need to figure out, obviously, the area of the whole circle, then take area of this half of the circle, and subtract the area of the triangle. So let's do this one. Let's try. Okay. Oh, 1 second. I'm sorry. Okay. I'm sorry. I lost the screen sharing somehow. All right. No, this wasn't it. Yeah, here we go. This was it. Actually, you know what? I have a better idea. Let me use this one instead. This will make it a little easier. Okay, I'm going to do number 5. Let me just set it up here. Just give me 1 second. I'm sorry, this is... Alright, I think we're going to do it this way. Okay, there we go. I think we are finally in business here. Alright, so this is number 5 on the homework. Okay. Points A, B, and C are on circle O as shown. If AC is 20, in other words, the entire AC is 20, so we'll call this side 10 and this side 10. I'm sure that's going to be important. AOB is 120. Okay. Okay, so we have to find BC, it's this segment over here, angle BAC, okay, and the area of the shaded region. Okay, let's start with the easy part. First of all, what is AB? Okay, well, AB, of course, has to also be 10, because all radii of the same circle have to be equal. This is a radius that's 10, this is a radius that's 10, so this radius has to be 10 as well. Now, what does this angle have to be? This angle, of course, has to be 60, because it's a linear pair. Okay. Now, if that's 20, okay, well, there's a whole bunch of things. First of all, this has to be equal to this because they're both radii, which means that this angle has to be equal to this angle because base angles of two equal sides are equal as well, which means that since this is 60 degrees, they all have to be 60 degrees because they have to equal 180 altogether. So this is 60 degrees, this is 60 degrees, which means it's an equilateral triangle. All the sides are equal, so this has to be 10 as well. Anyway, so this has to be 10, this has to be 10, etc. So BC has to be 10. And the reason is because OBC, or BOC, is an equilateral triangle. All the angles have to be, if all the angles are the same, that means it's an equilateral triangle, which means all the sides are the same as well. So BC is 10. Okay, what's angle BAC? Who can tell me that? 30, that's right. Because that's also, it's really, BOA, this triangle here, is actually an isosceles triangle because OB and OA are equal to each other. They're 10, so their base angles have to be equal as well. Since this is 120, there's 60 left over for these two, which means this is 30 degrees and this is 30 degrees. Okay, that's the easy part. Now we get to the area of the shaded region. And I'm going to harvest this diagram again because I want to be able to draw it a little bit clearer. Let's make this a little bigger to be able to, well, okay, close enough. All right. So what did we know? What do we know about this? We know that this is 10 and this is 10. So first of all, what's the area of the entire circle? How do we figure that out? Well, the area of the entire circle is, of course, pi r squared, like any other circle. The radius is 10, so the area is 10 squared times pi, which is 100 pi. Okay. So the area of the whole circle is 100 pi. Now, how do we figure out the area of the triangle, of this whole thing, of this triangle ABC, in order to subtract that from the 100 pi? Or actually, really subtract that from 50 pi because it's only half the circle. But let's take that as the next step. To figure out the area of this entire triangle, we need the base times height divided by 2. Now we have the base. The base is 20. You know, we need to figure out the area of triangle ABC. Okay. The base is 20. Now we got to figure out the height. Well, let's draw an altitude in order to try to figure out the height. Let's draw an altitude to here. This is whatever this line is is going to be the height. Okay. Well, this is an equilateral triangle, so of course the sides have to be equal to each other. Remember, this was 10, and this had to be 5. And this is a right triangle because it's an altitude. So now we can figure out what the black side is using the Pythagorean theorem. So using the Pythagorean theorem, we can say 5 squared plus x squared, again assuming this is x, equals 10 squared. So that gives us 25 plus x squared equals 100, and we've got x squared equals 75, which means x is the square root of 75. Once we have that, well, we know what the height is now. And there were probably other ways we could have gotten it. We could have been using a trigonometry. Hello, Devora, welcome. We could have gotten it using trigonometry because we knew that this was 60 degrees. We knew a whole bunch of things, so we could have figured out using trigonometry, but we figured it out the easy way. So instead, we figured out that the height was the square root of 75 using the Pythagorean theorem. Okay, so we know that the base times the height divided by 2. The area is the base times the height, 20 times the square root of 75, divided by 2. Well, this can cancel this, and that makes 10. So the area is 10 times the square root of 75, which means that our shaded region is half the circle, this whole semicircle here, which is half of 100 pi. So it's 50 pi minus 10 times the square root of 75. Now, if we did it on the calculator, 50 pi, well, what would 50 pi be? 50 times 3.14. So this would be 157.08, we'll call it. Minus 10 times the square root of 75. Well, square root of 75 is 8.66. So multiply that by 10. So it would be 157.08 minus approximately 86.6, giving us an approximate answer of 70.48, approximately. And again, these are all irrational numbers, so you're not going to be able to get it exactly, but it's close enough. All right. I think we'll do one more here. And let us try, we can do either 7 or 8. The other one you can do yourself. So how about 7? Why not? Okay. Let's get that in here. Okay. Let's do it. Okay, good. All right, here we go. In the figure, JP and PT are tangent to circle O at J. Okay, at J and T, JP is 10, UP is 5, PI is 6. Find the following. PT. Come on, folks. PT is 10, that's right. Why is PT 10? Because it's a tangent, and all tangents are the same. PJ is a tangent, and PJ is 10, so therefore PT is a tangent, and that has to be 10. That's an easy one. Okay, what's the radius? Now here, for the radius, you're going to need to use the tangent formula. Remember, the tangent rule was that the tangent and the secant, the tangent is the mean proportional between the outer part of the secant and the entire secant. So, let's take, which secant are we going to use, by the way? Which secant should we use? If we want to figure out the radius of circle O, which secant do we need? Well, that's the beginning. But yeah, we have to use the PUR, really. That's the secant we're going to use because that's the secant that runs through the middle. Now, PE, PIE, pi, is also a secant, but we don't need that secant yet because we're looking for the radius, and the radius is the one that runs through the middle anyway. Okay, so let's do the mean proportional. Again, we'll put 10 in the bottom of one fraction, put 10 on top of the other fraction, and we'll put 5 on this side. Good. Okay. And on the bottom over here, we'll use x plus 5. Exactly. Because we don't know x's. Oh, the truth is, we don't even really have to use x. Well, why make it more complicated? Why not just call it x? And then at the end, we'll call the whole POR, poor. We'll call the entire tangent, entire secant. We'll call it x. And then later on, we'll subtract 5 from it to get the diameter. Okay, but so we can do it this way. So let's cross multiply. 5 times x is 5x equals 100. Divide each side by 5, and you got x equals 20. And your way would have worked also. I mean, if you wanted to do it your way, it just would have been a little more complicated. Your way, it would have gone like this. It would have been 5 times 10 equals 10 over 5 over x plus 5, when you're talking about x being the diameter. And then you'd have 5x plus 25 equals 100. And so you'd have 5x equals 75, and x equals 15. And it's the same thing because this 20 refers to the entire PUR, whereas the 15 would refer to just the interior part of the circle. So either way, exactly. PUOR would be 20, exactly. Either way, any way you slice it. Which means that the diameter, which is the part inside the circle, would be 15, which means that each of the radii are 7.5. And finally, we've got EI. Where's EI? Okay. Well, how do we figure out EI? There are two ways we could do it. We can do it using the double secant rule, or we can do it using the same thing, the tangent secant rule. Let's do both. Let's do the secant rule, the SS rule, and we'll do the secant tangent rule. Let's do both just to make sure they come up with the same thing. Let's do the secant rule first, which means the external part of one side is proportional to the times the whole thing is equal to the external part of the other one times the whole thing. So let's do PR being the other secant. So that's 5 times the whole secant, PUOR, which is 20, equals 6, which is the external part of the PI secant, times x, which is the entire PIE. Well, let's figure it out that way. 5 times 20 is 100, equals 6x. So x equals what? 16 2/3. Right, 16.66. Okay. 16.66, which means IE is what? Which means IE is, right, you have to subtract the PI, because that's the external part, so it would be 10.66. Let's do it the other way. Let's do it with the secant tangent rule. Now the secant tangent rule, the tangent is 10, so we'll do this. 10 is the mean proportional, and we'll put the 6 up here, and we'll put the x down here for the whole PIE, with x being the whole PIE. And then we can cross multiply. 6 times 10 is 6x equals 100, and again equals x equals 16.66. And again, we'd have to subtract the PI in order to get the IE. Either way, IE becomes 10.66. Where did the 20 come from? Because that was the entire length of PUOR. In other words, in this one over here, we needed to do the external part times the entire secant equals the external part times the entire secant. Here, the external part was 5, whereas the entire secant was 5 plus 7.5 plus 7.5. No, PUR is not the same. They're both secants, but they're not equal to each other. They are proportional. If you multiply the external part times the entire thing, it will equal the external part times the entire thing of the other one. But they're not equal to each other. They both happen to be secants. But of course, PUOR is going to be a little bit longer than PIE. PIE, as we figured out, was going to be 16.6, whereas PUOR was 20 altogether. Let's say the green line was 20, because that's the external part, because that's the 5, plus the 7.5, plus the 7.5, that's 20 altogether. Whereas PIE, again, they're proportional. This part times the whole thing equals this part times the whole thing. Okay, I mean, the others in the homework, I think, are fairly similar to that. Let's see, 8 is really pretty much the same idea. You got to use the secant tangent rule as well. For here, this is something that really we discussed last time. By the way, for number 10, I'm not going to give you the answer, but for number 10, you're going to need to know what angle CBA is. Can anybody tell me what angle CBA is? It says the minute hand sweeps out 20 minutes. 20 minutes is how many degrees on a clock? It's 120 degrees. Why? Because 20 minutes is a third of an hour. A third of an hour means, in this case, a third of the whole circle. And the whole circle is 360 degrees, which means a third of it is going to be 120 degrees. Once you know that angle ABC is 120 degrees, well, then you can figure out the rest. They tell you the radius, they tell you the hand is 4 centimeters long, and the rest, hopefully, should be doable. Okay, so with that in mind, I think that's all we have for today. Next week we have a topic that's even a little bit easier, actually, I think. We have a little graphing. If you've taken algebra, next week is really going to be kind of a review. Maybe a couple of new things here and there, but mostly a review of what you covered in algebra already. If you didn't take algebra, that's okay. It's relatively simple stuff, graphing. And then after that, we've just got one class left in transformation, so we're really kind of winding up towards the end of the course. Like I always say, if you haven't started doing your homework yet, now would be a fantastic time to actually start. Please don't leave it for the last second. And if you have any questions, please let me know. I'm happy to try to help. And so, have a fantastic evening, everybody. Good night, thank you.